How does the astronauts read out
the gravitational effect of those planets.
Hey, I'm Kristen, and this is NASA Now. When it comes to designing spacecraft for travel, one size does not fit all. Something that works on the moon wouldn't necessarily work on Mars. Today, we'll talk to an expert about the challenges of creating the right craft with the features to match the mission. That's ahead. First, here's what's happening at NASA Now. After just 10 months following the historic announcement made by NASA Administrator Charles Bolden, the Space Launch System is ready to go to the preliminary design phase. The SLS, or Space Launch System, is a massive, heavy launch vehicle that will make it possible for explorers to reach far beyond our current limits to nearby asteroids, Mars, its moons, and destinations deep in our solar system. The first test flight of the SLS is scheduled for 2017. As you just heard about the SLS, extensive design is something that plays a major role in the development of any equipment used in space travel. Our expert today is here to share how physics and planetary environments factor into the design and development of vehicles that will transport and house future explorers.
My main responsibility is to figure out what humans will do once we get to many of these exploration destinations that we'd like to go to. For example, if we were going to return to the moon, what would we do with astronauts when we got there? If we were going to send astronauts to an asteroid, how would we explore that? If we were going to push all the way to Mars, how would we explore Mars? What would we do there? And if we were going to some of these interesting places in between, places called libration points, what would we do at places in deep space like that? When we're thinking about the design of hardware to take human crews to places like the moon, asteroids, Mars, the first thing we have to look at is the physics. And the physics on each of these places is different. The gravity is different, the amount of energy it takes to get there and to get back is different, the environments that we see once we get there is very different. The moon has a vacuum, Mars has a thin carbon dioxide atmosphere. So every piece of equipment is designed specifically for the place that we want to go. The first thing we do is we write down all the things that that vehicle has to do. We call these requirements. That's the language that the aerospace business uses to communicate. Once you figure out what it has to do, how fast does it have to go, how many people does it have to carry, how much cargo does it need to land, how long does it need to keep the crew alive, then you could start with those requirements and start designing things that will meet those requirements. So if I know I have to keep a crew of 4 alive for 7 days on the surface, that helps me design my life support system. If I know I have to land 8 metric tons of cargo on the surface, that helps me design my propulsion system and size my tanks. So once we understand what we have to do, then we start designing the vehicle. Then we actually turn it over to a contractor to build it. NASA really doesn't build too much hardware by itself. We use big aerospace companies to build the big spacecraft. When we think about building a lunar lander today, the first thing we do is we look at how they built it back in the Apollo days. The Apollo lunar lander was very, what we call bare bones. There was a lot of crew involvement required, and it used very old technology. It had computers on it, but the computer on the lunar module was far less powerful than the computer in your cell phone today. Now we could apply new technology to it. Our computers are very powerful. Our sensors are very good. So where Neil Armstrong had to take control of the lunar module, and because it was heading for some boulders, we think we could teach a machine how to spot boulders and alert the crew or just fly around them. You know, just tell the crew, hey, there's something dangerous out there, I'm just going to fly around it. And then, of course, there's been lots of advances in things like life support, and our spacesuits are much better and more flexible. The best part about my job is coming to work every day and not knowing exactly what I'm going to be doing. A lot of what we do here has no precedence. There's nobody who's ever sent somebody to Mars before, or there's nobody who's ever figured out how to anchor a space vehicle to an asteroid, or how to create a life support system that runs continuously for 2.5 years without breaking. So a lot of things we do here are very cutting edge, and I like those kind of problems.
A key component of designing a long-term mission is dealing with waste, both human and material. It's up to you to develop a solution to a real-world challenge.
Teachers, you and your students can gain greater insight into the world of mission design, coming up with your own plan to recycle materials. Check out the featured lesson, Transportation and Space, Reuse and Recycle. You'll find it on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.